Mr. Sutton here, bringing you the Algebra 2 10.5 Part 2 homework solutions on graphing the other trigonometric functions. In this one, we are focusing on secant and cosecant. To graph 3 cosecant of x, let's first describe the transformation. The 3 out here is giving us a vertical stretch. So the original parent table of cosecant, that's the one that goes from 0 to 2 pi. We've got some undefined asymptotes in there and also a 1 and a negative 1. So here is the new table transformed. Since nothing's happening inside the function, the x values are going to stay the same. The 3 outside is doing 3 times y as a rule here. So for the x's, we keep the originals, 0, pi over 2, pi, 3 pi over 2, and 2 pi. For the y values, we're doing 3 times all these. The undefined spots are going to still be undefined, so undefined, 3, undefined, negative 3, and you got it, undefined. So let's go ahead and graph this. For the x values, it looks like we can go by pi over 2's. For the y values, probably 1's will be good enough to capture the 3 and the negative 3. So we have our first asymptote that we're going to draw at 0. Next, we've got pi over 2 comma 3, and then another asymptote at pi, and then 3 pi over 2 comma negative 3, and then our last asymptote that we're drawing at 2 pi. So we've got one tooth up here and another one down here. To draw secant of 4x, let's go ahead and figure out the transformation. The 4 inside here is giving us a horizontal shrink since 4 is bigger than 1. So shrinking that horizontally. And then the original parent table, we've got our secant table from negative pi over 2 to 3 pi over 2. And let's go ahead and get the g function now. The 4 inside here means we're doing 1/4 times x for that rule. There's only an invisible 1 outside, so the y values are really just staying the same. For the x values, we're doing 1/4 times all these. So negative pi over 2 is now negative pi over 8. 0 is 0. Pi over 2 is pi over 8. Pi becomes pi over 4. And 3 pi over 2 now becomes 3 pi over 8. For the y values, these are all staying the same. So we've got undefined, 1, undefined, negative 1, and you got it, undefined. For my x values, for my scale on my graph, it looks like pi over 8 is a good one to go by here. And then the y values can just go by 1's. So I've got my first asymptote here at negative pi over 8. And then we have the point 0 comma 1. Another asymptote at pi over 8. And then we have pi over 4 comma negative 1. And then we have another asymptote at 3 pi over 8. So I've got one branch up here and another branch following the asymptotes down here, and that's it that we're going to draw for this one. Let's go ahead now and graph 4 cosecant of 1/2 x. For transformations, the 4 out here is giving us a vertical stretch. The 1/2 inside is also giving us a stretch, but horizontally. And now for the parent table, we're going from 0 to 2 pi with all the points in between there. And then for the g of x function, we've got a couple things going on. For the x's, this 1/2 inside means we're doing the reciprocal of that, 2 times x for the rules. And then the 4 out here means we're doing 4y. So for the x's, multiplying all these by 2, we've still got 0. And then pi over 2 becomes pi. Pi becomes 2 pi, 3 pi over 2 is 3 pi, and 2 pi times 2 is 4 pi. 4 times all the y values is going to give me, well, this is still undefined, but now we'll have 4, undefined, negative 4, and undefined again. So for x values, I can go by, it looks like pi. For y values, I could probably get away with going by 1's, or I could go by 2's or 4's. Doesn't really matter. I guess I'll go by 2's. So our first asymptote, we have 0 for that one. And then we have pi comma 4 right there. And then 2 pi is an asymptote. We have 3 pi comma negative 4 and asymptote at 4 pi. Then we have a branch up here and another branch down here. To graph 1/2 secant of pi times x, let's go ahead and get our transformations mapped out. The 1/2 outside gives us a vertical shrink. The pi inside, since pi is larger than 1, is giving us a horizontal shrink. For the parent table, we've got all the values from negative pi over 2 to 3 pi over 2. And for the g function, for the x's, the pi inside means we're multiplying by 1 over pi for the x's. And the 1/2 outside means we're doing 1/2 times y. So for the x values, multiplying all these out, negative pi over 2 times 1 over pi, the pi's cancel, so that's just negative 1/2. And then 0 is still 0. Pi over 2 becomes just 1/2. Pi becomes 1. And then 3 pi over 2 is just going to be 3 over 2. For the y values, undefined is still undefined. 1 is now 1/2. Undefined is undefined. We have negative 1/2 and then undefined. For the x scale, if I go by 1/2, that'll fit these nicely. And for the y scale, I'll probably want to go by 0.5s to fit these half values here. So we've got the asymptote at negative 1/2 right here. And then we have the point 0, 1/2 right there. Asymptote at x equals 1/2 is here. We have 1, negative 0.5 right here. And then 1.5 or 3/2 is our other asymptote. So there's a branch up here above the x-axis and another one down here below. For graphing 1/2 cosecant of pi over 4 times x, let's go ahead and figure out our transformations. We have a 1/2 outside, that's less than 1, so we have a vertical shrink. Inside, pi over 4, that's going to be less than 1, so that actually is going to be a horizontal stretch. And now for the parent table, cosecant goes from 0 to 2 pi, at least that's the first period that we typically graph is this one right here. Now for the g function, for the x's, since we're multiplying by pi over 2 in the function, that means we're multiplying by the reciprocal 4 over pi for the rule here. So we have 4 over pi times x. And then we are doing 1/2 times the y values for the output. So we have 4 over pi times all these x values. So I'm basically going to divide by pi and then multiply by 4 for each of these. 0 is still going to be 0, but now pi over 2, let's see here, dividing by that gives me 1/2, and then multiplying by 4 gives me 2. And then pi times 4 over pi gives me 4. 3 pi over 2, while dividing by pi cancels that, we have 3 times 4, which is 12, divided by 2 gives me 6. And you can see the pattern here. We're just going by 2, so this next one's going to be 8 in case you didn't multiply that out anyway. And then we're doing 1/2 times all these y values. The undefineds are still undefined, and then 1 becomes 1/2, undefined again, negative 1 becomes negative 1/2, and then undefined for that last spot. Graphing these out, if I make my x values go by 1s or 2s would be fine either way, depending on how I space things out. And then for the y values, 0.5s is going to work for those. So I have an asymptote at 0 right here. And then we have 2, 1/2, asymptote at 4, 6, negative 1/2, and an asymptote at 8. We've got one branch up here and another branch down there.